I'm so happy to be here with everyone today in this room. And in the next minutes, I will give this talk about our sharding database, distributed database system, especially around our RDS, about Amazon Aurora on the Kubernetes. So if anyone listened to one of the keynotes these days, you will find recently AWS released a new Aurora limitless database service. Actually, I just gave a look at their post, and I found its architecture is almost the same as today's one. So maybe today we can just listen to this topic, and also we can have a preview or Aurora limitless database service. So yeah, just some words to introduce myself. I'm Trista Pan, and now it's the CES co-founder and CTO. CES is the startup company which operated his works just around one of top-level projects of Apache Software Foundation. So because Apache ShardingSphere, it's the Apache Foundation open source project, and it's all around about the database sharding, around our RDS, around the cloud database. So today my talk will introduce some of the architecture, and the most one, I want to first introduce some of the real world case, and we analyze what's the new requirements about our database. And then I will give my solution to solve such the database issues, especially when people talk about the digital transformation that stuff. I did a lot of work in Apache Software Foundation, and because with the mentor hat, I can discuss a lot of big data stuff with other communities. And you found that the data security and distributed and Kubernetes, it's a really good topic recently. Next part is about my linkings. If any people today have a lot of questions, you can just we can talk more of in person or online. Yeah. So today's agenda, like I said before, we will firstly start with a real-world case because you know that the new technology or innovation, why it is come out. Because we want to leverage them to help us to resolve the real-world issue. So the first, I will give the real-world case, and we'll analyze this case to find what's the new requirements or expectation for our distributed database about our database service, especially on the Kubernetes, because you know that Kubernetes is so good, it's born for the stateless application. But how about the database? I know a lot of the database vendor and the open source project, they try to put the database on the Kubernetes. But today, actually, I can give another solution to rethink about this issue, Kubernetes and the databases. Yeah, and then I will give the background, the knowledge review, because I want to introduce more about the solution, but before, in order to enter into the solution briefly, I need to give a review about the background, about the database architecture. It's a little bit boring, but I think it's very necessary for us to understand our solution. At last part, I will give the load test case. It's a demo show because we listen to a lot of the paper stuff, and then we want to some of the practical part. So in this last part, I will give the load test to evaluate how performance it can help us improve, or what the functions it can give us, right? So that's all for today's agenda. And now, that's the very simple real-world case. I know if you're a team leader or you're a developer, you're the first requirements that's to launch your service to the market as soon as possible, right? So therefore, you can test its market fitting or not. At the beginning, it's very simple. Maybe you can just fill the service, and you can just use the EC2 to deploy all of them service. But for a data part, you didn't generate a lot of data, so just just the RDS, maybe it's the MySQL or PostgreSQL or Aurora, it's enough to manage your data. You can question a lot of the question about your queries from your data, and it will return your results very fast. It's okay, it's enough. But gradually you found that your application is so successful and people love your website. At this point, you found that just to use the EC2 to help you manage your stateless service is not enough. That's why we want to explore the Kubernetes service, like the EKS, to help us to manage our stateless service. That is the service orchestration stuff. But from the database point, and currently, we found that every day, every minute, there are a lot of the data generated from our end user, from our application. And just the RDS is not enough. So we hope some of the new database solution. Maybe Aurora is one of them, but we'll consider that if there are any other good solution can help us to provide the databases on the Kubernetes, on the cloud. That's the key point. So if we to understand the new requirements from the real-world case I introduced before, then we can look at this issue, the first one. If we just look at the database itself, we hope that its database solution, it has the high throughput and low latency, and it's very flexible and scalable. That means if we found that maybe today I just have a lot of the data to manage, then we can just skew in this database cluster. But one day we found we need more instances to help us to manage our data. Then we hope this solution, it can skew out automatically. So that's our needs. Because if we have the scalability, that means we can reach the cost efficiency. That's one of the key character of our cloud computing, right? So the same idea will apply to the database. It's the same thing stuff. And the next part, we also need to consider the migration. Because remember, at the beginning, you just have the RDS. And now, if you want to migrate to a new database solution, so how about the effort and time you spend on the migration stuff? You hope that I just spend a little bit of time, then I finish the migration. So that's another requirement or expectation at this point. Another part is that if we look at this issue from the application layer, then as the developer, or we are application itself, we don't need to want to take too much about your database service and what is happening in your database cluster. As an application or a developer, I just think your database service just give me an endpoint. And I can only talk with the endpoint, that's all. And I don't need to care about the high availability and how to do the skew in or skew out, or maybe I need to manage the connection pool to talk to the primary nodes and a replica instance of your database cluster, right? I don't need to I have no such capability, or I don't want to care too much about all the stuff. I hope there is just a stateless, single database service for me to talk. That's all. I don't want to care too much about database itself. It's your database project, your database vendor. That's your issue you need to address, right? So then the key point here is that could we provide our application living in the Kubernetes just a stateless, single database service? Right? So today, I want to address this issue because if we can address the issue, then we can meet all the requirements or expectations from all of the real-world case about how to manage our data, enormous data, and to provide the load balancing stuff or traffic management, and the high throughput, all the stuff. That's the key capabilities the application want or database vendor or projects can provide them. Yeah. So, but before we really enter into the solution, we need to give a little bit overview, a review about our traditional database cluster or the architecture. Because if we want to design a product, we need to base it on the idea. This idea will define what the pollution or solution will be in the future, right? So that's why we need to learn this background knowledge. The left one is the traditional RDS cluster. I guess most of you will know that if you want to talk your database, and maybe it's the MySQL or PostgreSQL, then you found at the beginning just the small data. So a monolithic database is enough. But if we want to do for example, the rewrite splitting, all of the traffic management stuff, then we need a lighter application to separately talk to the primary instance and replica instance. So at this point, you can see here, it's a very traditional RDS cluster architecture. But the right one, it's different. It's the shared disk or shared storage distributed database architecture. So you can see here, it's not a single one database. It's not monolithic. It has a lot of scalability and elasticity. Because here, this database architecture, it has a two-layer. The first one is the computing layer, right? The second one is the storage layer. They're split from each other. That means we can deploy them independently. For example, this storage cluster, actually this shared storage or shared disk distributed architecture, all of the computing nodes, they will visit the single one or shared storage. Like here is the cluster volume. Maybe it's the cloud computing storage. So it's the Aurora's architecture. And for the computing nodes, you can see here, it have different roles to take care about the global computing work. Computing work means you select something or you insert something. They don't care about how to persist the data. They just ran some the SQL, ran some the computing workflow. That's their capability. So it's the storage, the cluster, persistent data, manage your data state, right? So that's the shared disk or shared storage architecture. Actually, there's another distributed database architecture that's the shared nothing database cluster. The difference here, you can see it's not a shared or single database volume. You can see even though we split the computing layer and the storage layer, the storage of the nodes are independent from each other. That means, actually, if we found that storage it's close to their limitation, then we can just add more storage nodes into this data center or storage layer. So this storage layer, actually, each of them will just own partition of your whole data, right? So that's why we call the share nothing. There is nothing to share. And from the computing nodes, actually you can see here, it's different from the left one. They have no rows. Each of the computing nodes, they can handle all of the queries, all the type of queries, updating, modifying, insert, or just read something from your database. So all the computing nodes, they're equivalent to each other. And actually, we can regard them as stateless because their work just to take care the computing work, the global computing work. And it's your storage nodes, they will take care about persist your data and replicate your data from each other. Each of the tab of the architecture has its pros and cons, and I gave this table below. And for example, yes, we can see that share nothing, it gives us a lot of flexibility because it's real like the Lego. We use the Lego to maybe create the house or the tree, and here we can use the different computing nodes plus your different storage nodes, because they are all independent from each other, right? And to create your own distributed database cluster, right? It gives us a lot of flexibility, but at the same time, it will make the management work become complicated. So if we want to provide such database to our end user, we need also to consider how to make the management work less and less. Yeah. And now I consider that if we want to provide such stateless single database service for our application now living in the Kubernetes, maybe the question can become, could we consider that we just integrate the shared nothing database architecture into our Kubernetes? Because Kubernetes strives to manage the stateless service, right? But after our analytic, that we found that all of the computing nodes in the shared nothing architecture are equivalent, are stateless. They just take care about the computing work, right? So, like this picture shows, we can just deploy the computing nodes into our Kubernetes cluster and let our application talk with our computing nodes. Because computing nodes, they have no role. There's no primary one. There's no replica one. So for our application, they can just pick one of them and talk with them and let them run your query. That's all. But for our computing nodes, actually his work is a little bit more. Because first, it's the computing nodes talk to the storage nodes. You know that different storage nodes just processes partition of your data. So your computing nodes need to talk to different storage nodes and to let them to run the SQL to gather readouts. Yeah. And here, the computing nodes, it has another capability that do the load balancing stuff, because we don't want our application to talk with the primary nodes or the replica instance. And just to talk with your computing nodes. And computing nodes, it has the capability to analyze your SQL, to pass your SQL, and to find which replica or which primary nodes has your targeted data. And then it will automatically to do the load balancing stuff or traffic management stuff, right? And next part is about the computing nodes. It also have the capability can do the data sharding. Data sharding is the distributed database, and the key point here, because even though like the Aurora limitless service, they also use the sharding, this key architecture here. So the sharding means they can distribute the whole data among the different storage nodes. So that's the capability. So, but for the storage nodes, it's very easy here because you know that the storage nodes, their capability just to persist your data, to replicate your data, right? Help us to manage enormous data. So we can just leverage our existing RDS. Maybe it's the MySQL or PostgreSQL. Maybe it's the Aurora to working as the storage nodes. So another beauty of this architecture that we don't need to discard the original database cluster. Remember, because at the beginning, we have not so much data. We just use the RDS, MySQL on the premise, or RDS service. But now we need to consider, if we want to upgrade our existing RDS service into a distributed one, we also worry that maybe I need to spend a lot of efforts, the time to finish the migration work. But now, if we use this solution, we just leverage the existing RDS or your Aurora or your PostgreSQL on-premise to working as the storage layer, right? It help us to persist the data and help us to do the replication stuff. So now the question will become very easy. We just need to import or to introduce the computing, the role here, and to deploy computing nodes alongside our storage nodes, that's our RDS cluster, then we can upgrade your original RDS cluster become a distributed database one. So the question will become, who can work as the computing nodes? Here I will introduce this open source project. That is the Apache ShardingSphere. Apache ShardingSphere, like I said before, it's one of the top-level projects of Apache Software Foundation. So it's open source and already open source for over 6 years already. So it has a very active community, and it provides 2 clients for people to choose. The first one is ShardingSphere proxy. So when we mentioned that proxy, you know that it will become the perfect candidate to working as the computing nodes, because the proxy, it's really like the database gateway, and it can provide the database service for our application. So it's the capabilities to help us do the data sharding, data encryption, and how to do the load balancing stuff. That is the read-write splitting work. So our proxy can help us do all the stuff. That's one of the clients, ShardingSphere proxy. That's the capability. So it's perfect for us to use it to working as the computing nodes, and we can just deploy this proxy into our Kubernetes cluster and lighten all of the proxy to talk with our application. Then we can light our proxy to talk with the database. So you can see here all of the computing nodes that provide the facade for application. Application just talk to with the ShardingSphere proxy. They don't care about what is happening in this cluster. So the proxy will help the application to do the read-write splitting and to shard your data or distribute your data into different storage nodes. And it also has the capability to observe your capability of your storage nodes. If it found that one of the storage nodes just hit its capability limitation, then it will trigger the resharding that stuff. So we don't need to worry about that one day maybe my capabilities is not enough to help me manage enormous data. No, and now you have an unlimited database solution here. Another one that this project also provide a lot of the Helm chart or operator, so we can just use some of the Helm commands to help us to deploy all of the distributed database system here. And if you look at the image here, you found that when you, after deployment and you log in, you found that the CLI is very familiar because it's really like your PostgreSQL CLI or MySQL CLI. So you can just talk to the ShardingSphere proxy, this new database cluster, in the way you talk with your original RDS. So it's very easy and simple. The next part that will about how to deploy it. Here I gave this example that I used the Aurora database working as the storage nodes. And I used the 3 commands to use the Helm charts to deploy the whole cluster. And here, the computing nodes is the ShardingSphere proxy. And the storage nodes, it's our Aurora database cluster. And if we found that maybe at this point, the 3 Aurora cluster is enough, and then the next day, if you found that you need more storage nodes, then don't worry about that part. You can just tell ShardingSphere and its operator, and it will help you pull up more storage nodes. So it's very flexible, and that means we have an unlimited database or storage here. But if you think that, oh, I just want to cut down some of the cost of our database service, then the ShardingSphere proxy will to help us to reshard your data and to put some of the data from maybe the 3-1 become the only 1 database cluster. So that's the capability. It's very flexible and scalable. So the next part is about ShardingSphere, how to handle your SQL. I give the two example here. The first one that how to define your sharding table, because SQL is the language we talk to our database. So here, you remember, we just leverage our existing RDS or Aurora, right? So you can just run some of the Postgres or SQL or MySQL SQL in your database cluster. And now it's work same here. But if we want to run some of the sharding feature, we want to tell this new distributed database system that, hey, please help me to do the sharding work, to do the load balancing work. Now we need to use this new SQL. It's the SQL diet. That's the distributed SQL. For example here, I gave you an example here. If we want to just create a single table, then you can just create a table to user, right? That's all. But now we hope that ShardingSphere proxy helps to create a sharding table. That means this sharding table, they have a lot of partition. They have a lot of shards located in different storage nodes. So here I give example. We use this distributed SQL, create sharding table root for T-user. And in this destination, I define that I need to create the 4 shards for this table. And I hope that I use the mathematics module 4 to generate all of the data, all of the subtable. And I also define that the sharding key, it's real like the primary key, it's the user ID. So I use the distributed SQL to define how to shard my data, how to shard my table. And just to execute this SQL, and it will help us to create all of the shards in different storage nodes or database cluster. Here, there are just 2 clusters you can see here. The left one, it's the one of the primary and plus the replica compromise RDS cluster. That is the one of the shard cluster. And the right one is same as the left one. So now we have 2 shard cluster. Each of them have a primary one and a replica one. And ShardingSphere will connect to all of them, and it will automatically create all of the subtables or partitions of this T-table user in different shards. So that is a capability. And if we want to get something or question or database, please help me get some of the data from my whole database cluster. For example, here it's very simple. We just select everything or select star from T-user, and the condition is user ID equals 1. So when ShardingSphere receives this query, it will go through the following steps. The first one, it will pass SQL. We call it the proxy. Actually, we just think, oh, it's just maybe database gateway, but actually, all of the steps happening in your database and now will happen same in your proxy. It will also pass your SQL, generate the AST, and if it found that this SQL may be drawing many tables and it can do some optimization, it will help you do the SQL optimization. And it will also do some of the rewriting work, because actually in your RDS database, there is the node table named T-user. Maybe they're just the shards have the different name. So it will rewrite your SQL. ShardingSphere proxy will talk to different the local database, the shards, your RDS, and light them to run the local computing work and get the local results and return the result to the ShardingSphere proxy. And proxy, it will do the global workflow. For example, it will merge your partition computing result, become a final one, and return that to your application. So that is a work. That's why we call it stateless, because it just do some of the computing workflow from the global view. So here, when we talk about, there is one important I need to introduce, that is the route. SQL route is very important because the first one, it's the distributed one. So ShardingSphere process needed to do the first route, that is to calculate which partition or which RDS cluster has your data, has your target data. But here it's very simple because we just use the sharding key. Sharding key is the primary key, right? And our sharding algorithm, we just use the mathematics mod 4 to get your data, right? Here we use the sharding key, sharding algorithm to calculate which partition. This case is very simple. They're just the poor partition or partias, but in our customers' environment, they have thousands of the shards. So our ShardingSphere process will to calculate which shard has your data. And then it will send the requests to that data to ask that shards, hey, please give me your data, I need your help. And then your RDS, maybe it's the MySQL or PostgreSQL or Aurora, will run that the local computing and return the result to your ShardingSphere process. And sharding process then will merge the data and become the final one to your end user. Another route here is the load balance work. Because if we look at it, we hope that the ShardingSphere process really work as the gateway and to help us to do the read-write splitting, to help us to pick up one of the replica to run these times of the SQL, right? So here, for example, in the first shards, that maybe here just the one replica. So ShardingSphere process this process just send the query to this replica. But it found that if there are maybe 2 or 3 replicas in this shard cluster, then it will use some of the strategy. For example, the round robin or just randomly pick up one of the replica to run this SQL. That means it can help us automatically do the load balancing stuff. Our application, they don't care all of them. They just pick up one of the process, tell him, hey, please get the data from which one. And then the remaining work that will be done by ShardingSphere proxy. The next part is our load test case because we learn a lot about the architecture or about the mechanism stuff. And then I will give this load test that us to evaluate how performance they can help us to improve. And here I just quickly give the results that by use this distributed solution, it's not just to help us to upgrade our RDS into a distributed one. It also can improve the performance. Like here, the figure is 5,018% improved under the TPS and the QPS. Another metric is the latency, right? And latency here, it's reduced by 19% of, that's the number. So it's a good result. And how to get the result, I gave this the load balance case. The left one, I just list all of the database instance or benchmark tool here or the proxy, the stuff. And right one, it's our test subject. The left one, just one Aurora, right? We can evaluate what's the performance of the single one Aurora. But right one, it's a distributed one. The storage layer, we use the 3 Aurora database or cluster. And for the computing nodes, we just deploy 2 proxy here. All of them can handle every type of the query, modify, updating, insert, or delete, or just read. So they can do the load balance stuff, the proxy. In the application, we just use the sysbench. It's the benchmark tool for the database here. And for the data part, we just put 3 TPS data in the single one Aurora on the light architecture. And the distributed one, because it's a distributed, we can just split 3 TB data into 3 Aurora database cluster. So it can help us to, just to split a massive data into a lot of the small one. And we can run the querying simultaneously and to get the result in parallel. So that's the magic of the distributed database system. Yeah, so we just select the Sysbench to simulate there are 200 customers visit our database. So the concurrency is 200. And we, after do all of the tests, and you will get the results here, the QPS and the TPS and the low latency here. And here I just give a little bit details about the benchmark SQL, this Sysbench. This is how to run the Sysbench. And this, each of the query will consider the following statements. That means we run all the querying, the delete, update, or begin or commit of the queries to test, to do this load test. And then you know that we just get a result here. And the 518% improve on the QPS, and the latency is also reduced a lot. So that's what we want. We hope our database can provide the high throughput, low latency, and it can skew in, skew out automatically. But in this low test case, actually, I didn't give too much test on the functions. But if you have a look at his website, you found that it not just help us to do the load balancing or the data distributed, all the stuff, it can also have the security feature, that's the data encryption. Because now when we talk the data, we really care about my private data, my private information, and ShardingSphere process is not just to help us to do a load balancing or to do the SQL, the data distributed stuff. It also can help us to do the data encryption. So we can just put all of the important expectation or features into these single solutions here. In this test, actually, I just used the commercial release of ShardingSphere. But if you want to have a try, just to use some of the open source one. And I guess they have the same number here. Yeah, so the next part, we just give a review here. So the first one about the database and how to choose a database. Today, we introduced a lot of the distributed one. It's really good, especially if you see a lot of other databases that have a MongoDB or YugabyDB or Aurora. Actually, we already want to use a lot of sharding architecture to help us to create our distributed database system. But if your data is not so much, I guess at the beginning, actually the RDS or just a single Aurora is enough. We don't need to give a lot of burden at the beginning to just use a very big data solution. It's not the best one. So if your data is moderate, just start with the RDS or cluster PostgreSQL, MySQL, or Aurora is enough. But I also will give a suggestion that even though at the beginning you have not a massive data, you still need to consider how to do the migration stuff. Because if you want to do the database migration, that means you need to reinvent your database infrastructure. That will create a lot of tedious work. So at the beginning, you need to consider how to make my database that's flexible or scalable. That's the key point. The second one that we review a lot of the shared nothing or shared everything or shared storage, all of the architecture. It's all the paper knowledge, but I think it's very useful. Because if I'm a new one that I want to pick up a database solution, how do I evaluate this is good or not? I guess all of the theory or this mechanism will help us to evaluate one of the database solution. Because you know, like the person that's our gene at the beginning will define where maybe later on the environment will play a bigger role in your life, but at the beginning, at the first, that the gene is very important. And same here, we learn a lot of the architecture or theory that can help us to first know that the database will be happen in the future. So that's another one. The third one, it's about Apache ShardingSphere. That it's a very popular, I mean, because this idea, I guess most of the database solution, they share the same idea here. So we can just pick up one of have the good brand or have a lot of user or has a lot of user cases for us to choose. And the next part is about Kubernetes and databases. Like the beginning, I said that currently I found a lot of the database vendor or the open source projects, they're trying to put our favorite PostgreSQL into the Kubernetes. But currently, it's a little bit complicated for us to manage it because we need to consider the cluster API and the headless service to help us to do the load balance stuff. We also need to consider how to use the storage class to define the storage part, right? So if we look at this, if we want to solve that issue, maybe we can regard this issue from another perspective, like today's solution. We don't need just to put our database really into our Kubernetes cluster. We can just to split two parts because the distributed database architecture, they already split from each other, right? So here we can leverage that's the key point. We can just select all of the stateful parts and belong to our RDS. And all of our RDS, they can find their home anywhere. Maybe on the premise, it's okay. Maybe on the cloud, wonderful cloud, it's cool. And today it's AWS, maybe next day it's other cloud platform. It's fine, and we can just use them. But we can just deploy our computing nodes. They're stateless. They're very perfect for the Kubernetes. And just split two parts, deploy our stateless part into Kubernetes, and let our existing RDS or cloud database vendor to handle the very complicated part, persist your data, right? That's the key point of today's talk. But I also very look forward to the future. Maybe our Kubernetes now, you know that they already realize that maybe I need to consider the stateful application living in my Kubernetes cluster. So maybe one day we found that Kubernetes now evolve into another type or another release. They are really good for every service. That's perfect. That's one of the direction we can look forward that. But another one that maybe it's our database. They really consider their architecture and they really leverage the Kubernetes capability to help them to create their database solution. So there are two different upside directions for the Kubernetes developer or the database developer to consider. But what will happen in the future, I have no idea. So, I mean, that will become the good trend for the future, and we can consider about all the part. Because we all know that if a person, they can not to manage all of the thousands of your stateless or databases. That's why we want to use the EKS. We want to use the cloud database service, right? So, and now if we really put all of your application into Kubernetes, how about your database? Because in our international world, there are only two workload tabs. The first one, computing. The second one, it's persistent data. The data part, computing part. That's the basic point here. So when we consider our database, consider our stateless service, consider our stateful service, and that's all about these two parts. Yeah, so that's all the point about today. I mean, all of the agenda will finish here. And if everyone have some questions, because we are the last talk, so we can just have some talk off the stage and just one by one or talk more about our topic. Yeah, that's all. Thanks.